Hello and welcome back. Okay, so what I've got here is a selection of breadboards and I want to put them through their paces a little bit and see if I can work out which ones I want to purchase for the next stage in CPU construction. And I figured this might be something that's of interest to some of you guys as well. Now, these range in price from the cheapest on eBay through to the more expensive ones that at least I was prepared to pay for. We're going to see if that makes much of a difference. First up, we've got the Key Studio 830 tie point breadboard. Now, the seller I bought these from sells them in a pack of 3. That was for £8.59, so that's £2.86 each. So these are the cheapest ones in my test. Now, the first thing I see is that they do have the constant bus bars for power. A lot of the earlier breadboards I purchased in the CPU build series had a kind of split rail here, so I had to join them up with little wires. And not only was that annoying, but it also added just extra joins in the whole kind of power loop that I think contributed to some of the power losses I experienced. These are the breadboards I was using then. You can see the split rail. Now these are compatible with these as well for the clips. That's handy. You can see the plastic on these looks a little bit yellower. So these are the Elegoo ones. I've used these on some of the more recent projects I've had, and a few people were commenting saying they've had trouble with these in the past. And that's actually one of the things that prompted this whole review video. So these also have compatible clips with the pre-existing breadboards I've got. Now, the plastic on these actually feels quite nice. It's got less of a flexible feel to it. I quite like those when I first opened these up. I have had trouble getting wires into these holes occasionally though, so I definitely want to do a test of doing that to a whole bunch. These were £8.99 for a pack of 3, so this is £3 each. These are Sunfounder boards, and slightly complicated pricing here in that they come in a pack of 3 but with 2 of these. So the pack of 3 was £10.99, and so I've kind of estimated roughly the price on one of these as £3.14. I've counted them as 3.5. These are not quite compatible. It looks really close. It doesn't quite line up. So once again, no split rail. I think most vendors have just switched to not having the split rail. This is labelled as ZY white. These look very similar to the original ones I had. Even got the same colour backing. Slightly different tone. Printing's a bit faded in a few places. Plastic on these feels a little bit flexible. Now this is basically supposed to be a clear version of this. So I don't know if any of my tests are going to show up different results apart from maybe just the plastic itself. Yeah, the plastic here feels less flexible. You can see the internal structure of all of these. Pretty much what was expected. I quite like the transparent, but I'm not sure if it really makes any difference at all to building circuits. I also suspect the electrics inside this are going to be exactly the same as on here, so we won't see any difference in the springs. Okay, so this is Confly. Seems to be the only trade name out on here. So yellower plastic like the first one. Printing looks slightly better. See the alignment on this one, the printing is a bit off. Everything has this same peelable foam backing, but this one is white and it feels a bit less flexible. MB102. Now these packets I remember as being what I had here. So we're still seeing some variation in the plastic colour. It may just be common packaging. I bought these from Hobby Components, £5.20 each. Now of the boards I've used so far, these ones I think are the better ones. Now, I first showed a bunch of these breadboards in a mailbag a while ago, and several comments on that video told me I should get the BB830 breadboards off Mouser, and that's what this is. This is quite a bit more expensive than the others. This is £7.97 each. Printing on it is very clear though. Curiously enough, it's the only one with red and black rather than red and blue. And they're not compatible with all the others. Is it compatible with the Sunfounder? Interesting. Appears to be a piece of metal. No idea what that's for. Check the comments, someone will probably tell me. Foam isn't perfectly aligned on the back though. I do admit my initial impression of these is that they are good quality. Fundamentally though, they are the same design as all of the others, apart from they're not physically compatible with them for plugging in. This was an interesting one. From the recommendations, I wanted to get hold of the BB830, and whilst I found them on Mouser quite easily, I didn't have anything else at the time to order with them, and so the postage would have been quite high. So I searched on eBay, and there was a listing that claimed to be BB830s, and what actually arrived was one of these, BX4112N. It's curious because it's 840 tie point, not 830. Visually quite a bit different from the others. Probably the better packaging, but this is radically different in size than those other ones. Got the plastic backing. Wasn't expecting that. Little rubber feet, but no self-adhesive. It's got round holes rather than square ones, and it does have the split rail. This one came in at the most expensive, £10.81. I got the impression this is a very high quality board. I can't tell how flexible the plastic is because of the backing plastic. Okay, so on these I want to test the clips mechanically, see how easy it is to insert things and how many holes I have trouble pushing things into. I also want to test the connections electrically, because I'm quite interested in that, because we want to both be able to plug stuff into a breadboard easily, but we also want a good sound electrical connection. And I think I might try and take a look at some of the metal clips, although I might be scuppered a little bit on this one. See if there's a visual difference there. Now, when I was planning this video, there was a stream from Brian Locke, and he said one of the things that he values about a breadboard is the ability to plug a module in without needing to force it too much. I'm going to make up one of these Arduinos and I'm going to try plugging it into the breadboard in a few places. Right, so this is one of my fairly heavily used breadboards of late. Now, how am I going to score this? I think what I'm going to do is I'm going to try and insert this in, say, 3 locations. No, let's make it 5 locations, 2 of which are going to overlap some of the pre-existing spots, and just see if a fairly constant level of force will get the module in. Okay, so that went in 4 out of 5. I was a bit generous pushing it in that last time because it felt like it might go. My biggest complaint about these so far is it's difficult to push pins in to some but not all holes, and that is certainly borne out there. 0 out of 5. The Sunfounder. That was a bit borderline, but it did go in without too much wiggling around. Popped one of these solder joints, but I'm going to give that to it. No doubt everyone watching this noticed I missed that solder joint properly. That was a bit borderline as well. A little bit of a push might be a good thing because we do want it to grip wires properly. That is going to be our first 5. Now this is the one that we think is probably the same internally. Felt slightly more resistant, but it did go in without wiggling. Definitely gripping it well though. Okay, so that's also 5. Not surprisingly, it basically felt the same. This is the confly. That was very borderline. Okay, that kind of felt like a snap in, but it went in quite nicely. Yeah, there's some odd resistance there, but not actually causing me a problem. That was the hardest I had to push of any of the ones that have scored 5. But it did actually go into all the locations. Here's the MB102. Assuming this is the same as the ones on the CPU, I have had occasional difficulty. That's not scored brilliantly for the insertion test. Now these were really easy to insert, and then they were quite tough to pull back out. So it's like the metal work in here is gripping the pins quite well. This is showing promise. For the most expensive one with different looking holes, I'm not very impressed. I want to test how good the contacts on these are. My 5-volt supply. So as expected, we're going to measure pretty much 5 volts straight off the bat. But the situation I've fallen into problems before is when I have kind of daisy-chained connections. So I've got 10 breadboard cables here. Now this is taking the 5-volt line and creating a large number of junctions, which should have a resistance. Now I could just test the voltage here to see what the drop is. Not really showing much up there. But instead what I want to do is put a bit of a load across it. So here's a 470 ohm resistor. Now I want to test the voltage drop between the 2 pins that should be 5 volts. Previously on the breadboard I've been testing what should be 5 volts and seeing a drop as we go further from where the power input terminals are. But if I test the drop itself, then I can drop this to a higher precision section. Let's go the other way to get a positive result. 203 millivolts. .3. Seems to be oddly varying. Now I did clean these terminals down before starting, so there shouldn't be much in the way of variance as we go on. Don't even know what kind of number I'm supposed to put to this. They're all over the place. I'm going to put 109 there as the last figure I saw. This is of course why once the breadboard CPU got to a certain level of complexity, I had to start getting very careful about, well, seemingly breathing over some of the wires sometimes. It's possible the better test on here is just how much the numbers are dancing around. Quite 51. Now my suspicion was that this and the one before had the same contacts. The results on this test might not be particularly great. Mind you, it does seem so far that the ones where it was more difficult to poke pins in had the better connection, which may just mean they had the tighter grip. Okay, the pin doesn't want to go all the way in that hole. Bad holes like that are the bane of project development, particularly when you start trying to poke a chip in. There's a second bad hole. That one was tough. Call it 54. $37. Splash one wire. Just cleaned up a spare. $14.9. Okay, so that's coming out as 11.3. Now, because of the split rail, I had to bring that back a bit closer. I won't override the result on that, but I'd be curious to see what happens if I put these jumpers in. Because if we were building a circuit with this, we'd have to do that. Still very low. So that's held with the trend that the ones that where it was more difficult to do pin insertions are coming out on average to be lower resistance. But then this BB830 is a bit of an outlier in that it's the second lowest resistance and we didn't have any pinning difficulty. Okay, this is the Fifo buffer I did in the last video I recorded. I've got these dip switches on here, and you see I've actually got them mounted on top of some turned pinned headers, because it's the only way I can make them stay in these breadboards well. So I want to test on these whether or not objects like these dip switches with the slightly shorter pins actually can stay down. Yes, not very securely. I'm going to give that a 3 out of 5. Ergo, that pops straight out on its own. So that's a 0 out of 5. I knew that was going to happen. The Sun Founder grips it a little bit better actually. I'm going to call that a 4 out of 5. That won't stay down at all. So that's a 0. That's interesting. There are definitely some notable differences between the white and the clear version of these. It's not the best grip. We call that a 3. It's the Confly. That stayed in the first time, but it's popping out all the other times. Let's call that a 1. It stays in, and that was fairly solid. That feels actually quite usable. And I'm going to have to call that a 5. It does stay in. Not best grip though. Call that a 3. Yeah, that's a 0. Not sure how scientific this is, but I'm definitely interested in the breadboards that will actually take this without needing secondary pins. There's a few switches that have a similar problem. Something like Arduino is never going to have a problem with great big long pins like this if you can actually get it in. Okay, the final test I had to leave to last because it's going to end up being destructive. What I want to do is take a look at the metal bits inside, because that seems to be the biggest difference between them. Made up a little bit of a sticky back card here. I'm hoping I can stick them all on. At a glance, these all look pretty similar so far. So I don't know if this is a difference in the sticky material or its adhesion to the plastic, but this is practically falling apart on me. Probably wouldn't be appropriate to rate these things on ease of disassembly of contacts. Okay, so the plastic totally fell apart on that one as well. Don't quite know how to deal with this one. There is a screw underneath. At least there's no foam to contend with. Right. Okay, there seems to be a strong deviation between the ones that have a more rounded hull and the ones with a more slit-like hull. But there doesn't seem to be any correlation between that and the ease of pin insertion. So the ones that were really difficult was number 2, the L-Ego, and number 9 was a complete fail as well. That's the 840 pin one. So in the BB830, we got 5 module insertions without a problem. Mind you, the gaps in this one are bigger than in a lot of the others, which might explain why it had the second highest voltage drop. Don't see a credible reason why this one would though. That's interesting. I certainly don't feel like I can say one particular design is better than the others. What I would say is this, I see a slight coppery tint to the metal. So it may be an actual materials difference. So it could be the alloy composition of these affects the resistance and the springiness of it and the flexibility. Okay, well that was interesting. I'm going to see if I can reassemble these now. I don't know if these rubber feet stand any chance of going back in well. Now here's a side thing I don't like about this one. When I stick lots of breadboards together, I like to share the power rail on it to keep it quite compact. And these have a larger gap between the power rail and the pin points, and it's not easy to take the extra power rail out. So all in all, these would take up quite a lot of extra room if I tried to make a large build out of it. Once again, I don't know if ease of disassembly and reassembly should be something I judge these things on. Okay, well, I hope you found this interesting. Now, this one at the end is clearly the outlier. It's got a different form factor and a different design than the others. It did have the lowest resistance contacts of all of the breadboards, but some of the others came quite close to it. But it was very difficult to poke stuff into the holes. It's the only one without the sticky backing. It's the difference in the spacing which is really putting me off these. I also don't like the fact that the item description on eBay didn't really match the breadboard I received. Now, these are arranged in order of how much they cost, roughly, although the multi-pack purchases gives a little bit of ambiguity into some of the pricing. Now, 4, 5 and 7, I believe all actually come from the same manufacturer. So I was actually surprised to see as much variation between them in all of the tests as there were. These two look like similar plastic, but these aren't. It's actually the transparent one did quite well in some of the tests. In the insertion test, I got 5. These all got 5. I got 4. So in the resistance test, that was the highest. That was pretty high. And this is the only one that held the dip switches well. Everything else was pretty ropey. Okay, so at the cheaper end, these ones were probably better all-rounders. And I'm partially basing that on the fact that there's a bit of variation on these, and I suspect these contacts are all the same, and we've just got not the best consistency on these. I'm honestly not really surprised by this, but the BB30 that everyone recommended to me really is a bit of an outstanding one in this test. Had the second lowest resistance, had very consistent ability to poke wires into the hole, even held the dip switch quite well. Slightly frustrating that the brackets on it don't quite line up with any of my existing breadboards. Now I had to buy all of these breadboards directly, so this isn't a sponsored video at all, so none of this is biased. But the Elego ones, they're pretty bad for being able to poke stuff in, but I found their general behaviour, apart from that, to be quite consistent. So they're not terrible. MB102s, this I think is what I used on most of my build. And I mean, they're kind of middle of the road. I've been generally happy with those, particularly when I picked up other breadboards and discovered they were much worse. So you could do worse than these. And they are less than half the price of the BB30s. But particularly the projects I've got coming up, I've got to do a bit of I/O, bit of audio, and I want to do my video circuit. And the video circuit is going to have some pretty tough wiring and some fairly high frequency components. And I think it's going to be very sensitive to loose wiring. And so I'm going to invest in a few of these for that video circuit. And I think between the breadboards I've already got and the ones from here that will fit my existing breadboards, I think I'll probably cobble together the ones I need for the other bits of the build. Of course, coming from Mauser, this is the only one I can't provide any kind of a affiliate link for, but these are really good. Hope you found this interesting, and I hope some of you at least found it useful. So thanks a lot for watching. Goodbye.